these vaccines, whenever they are given to people in, for example, Pakistan, they say, no, Bill Gates is sending these tiny little chips into our bodies and they will eliminate the God gene from our brain and we will become godless. You know, these kinds of things that are coming together, how can you actually do this? So the radio frequency identifier, where this is the chip, I actually have a chip if anybody wants to see, implanted in myself. So I did first experiment with myself. So this can really not only release your vaccines, but also has identification whether you have vaccinated or not. I'm going back to Canada. I have 5 different documents that I have to show. Now they don't care if in my suitcase I'm carrying something, you know, nasty. कब भला अपने बुजुर्गों से ये कम लाते हैं, वो सनम लाते थे मस्जिद में ये बम लाते हैं. So I'm not going to really bring anything, but the idea really will be that can we use now your, all credit card information on small little chip, and all you have to do is bring it closer to the radio reader and you can read. As I said earlier, that you can also use these, for the rare genetic diseases. You have the ability to be able to actually take the snippets and determine if a baby is yet to be born will have any genetic abnormalities, and whether those genetic abnormalities could then be fixed using CRISPR gene editing technologies to take out that defective gene for Down syndrome, for other things, and replace it with something that is a healthy gene. So this is also for youth. It's really important to get involved in these kinds of technologies because this is where the future of medicine really is. And then we think about, how is it possible that you could do large data and transfer it with G5? It is becoming possible for you to be able to operate an entire OR, an operating room, using this powerful, G5 technology. Quantum and cloud computing is becoming another very powerful tool. These were the rate limiting factors for us to be able to do things because of the bandwidth limitation. But now with these technologies coming on board, I think sky is really the limit. Remote diagnostics and surgery, surgeons could sit, for example, in Chicago and perform surgeries here in Atlanta. This is also becoming a possibility. In our hospital, this is what is now being done, where a surgeon is in a very different room. The live image is projected on the screen. And you know who developed that technology? Was these kids from grades 8 and 9. They play with joysticks. They're really good at playing games. They are the ones who developed the haptics. So let these kids play those games, okay? The other idea is that you can create a hybrid operating room where these robots will be working with surgeons to be able to perform surgeries. And these surgeries are much more really exquisite in that sense. 3D printings, when somebody comes with a brain tumor, you heard about gliomas, they're really nasty tumors and they spread so fast they're closer to metacerebral artery and a surgeon touches the artery, that's it, the game over. But now what you could do is that actually print the entire MRI image in the brain of that individual and then design and plan your surgery so you will eliminate any mistakes that will be made in an OR. Similarly, 3D printing can allow you to really do precision or personalized limbs, for example, the bones and joints and cartilages and these aspects. So artificial intelligence and machine learning, this is really very close to my heart because I think artificial intelligence and machine learning is the way forward. So our youth need to embrace these. Do not get scared or afraid of these technologies because if you miss this boat, you will miss the boat. Virtual reality is another very important area whereby for psychiatric disorders and people who have mental health issues or autism spectrum, ADHD, you could really use these technologies to reprogram the brain, especially in young people. So you reprogram brain after stroke, trauma, injury, Parkinson's, and many other diseases. You will see these little robots, little fellows during COVID-19 running around our hospitals because these robots can do what a nurse normally wouldn't like to do. And they will not only take your vital signs, give you your pills, but also provide you with food without actually exposing healthcare professionals to a patient who is really sick. Now this part is my personal story. There was a young girl and she was brought to our children's hospital. I was the scientific director. And this young girl was 13 years of age. She got a little bit sick. Parents thought that she's got cold. They gave her Tylenol. She got worse, brought into emergency intensive care, and she was moved into ICU immediately. And 48 hours later, she passed away. So nobody really knew what was wrong with this healthy girl, so I was asked to take the brain and see what was really the issue. And when you open up the brain and the brain sits in front of you, you get really the shock of your life. You realize that, you know, this piece of tissue is just a small piece of tissue. And then you begin to think, how is it possible that all her thoughts, memories, her emotions, affections, you know, her choti baat pe ladna, doston se naraz ho jana, you know, all of these aspects, how is it that each and every component was in that piece of tissue, which was biological, but many things like feelings and beliefs, even the concept of God, you know, and we cannot really observe and manage it. So what we wanted to do was to figure out how to figure out different parts of the brain and how the brain functions. And you know, during my PhD, I reported from 12 brain cells, and I thought I walked on water, only to realize that I was the dumbest person on the planet. How could 12 brain cells allow me to understand how brain functions? And so that was the one really major issue. The other issue is if your brain is damaged, either due to stroke, trauma, injury, Parkinson's, Alzheimer's disease, natural replacement of damaged brain tissue does not take place. The neuroplasticity plays an important role, and it helps you to recapitulate some of the function, but it will not be able to replace the damaged brain tissue. So how do you really go about doing this? So we thought that we need to develop a semiconductor device, engineer a device whereby brain cells can talk to a semiconductor chip, and semiconductor chip can talk back to the brain cells. So you create a bionic hybrid whereby an engineered chip or a machine can talk to the brain, and then the brain can talk back to it. So this is really a paradigm thought. When you take a nap and you wake up, you say you have to really do something. So brain chip and computer interfacing, this is really exciting for students, because in my lab, I'll show you that we can fly a drone by just thinking about it. We can drive a car by just thinking about it. The car is sitting there, you're not attached, there's no remote control. You will ask this car to move, and it moves. You turn left or turn right by just using subcortical implants. You don't have to implant inside the brain, but just outside the scalp, you can do this. And I'll show you some of that. But how do we do this? Because we are naturally cyborgs. We attach to the machine naturally. So I am attached to this remote control, it's attached to my computer. We attach to devices, so it's really not that hard. People will think, how is it possible to connect computers with brain? It's really not a rocket science. Our brain is absolutely incredible. The unconscious part of your brain, it scans 1.2 million frames per second, whereas the conscious part of the brain scans only 42,000 frames per second. So you know that the unconscious brain, if you can tap into its firepower, that allows you to give you, maybe 10 GD network, and you could perform some really cool stuff with this. So the idea really, watch this particular video, where one of our students really has, these electrodes attached to just outside, and whatever Thomas will do, this little robot, which is a monkey, will mimic all of those steps.
Can you please turn the red light on?
We can even turn the lights on in the lab by just thinking about this. So you are really using brain-computer interfacing technology, whereby we can bring in young students in the lab. They have never been exposed or trained, but through their own, they can actually play a robotic game. So the idea here is that this particular cube, we train them to raise this cube inside the tunnel, go forward or backwards or up and down, and this is what we use and make them fly for example, a drone. And so normally kids get caught because they have all these consoles in their hands, and they don't have to do this, right? You can play these games as you like. Driving the car, but just thinking about this, it actually drives better than Google cars. and then flying a drone, by just thinking about it, the student is only thinking, and you can get, you're always careful that Dean is not around, but, you know. So very tight space in the lab, you can fly this drone by just mind control. So it's just brain control, devices. My technician is Pakistani, so I said, next time you will see people just thinking and the plane will be fine. He says, what a big deal. In Pakistan, the pilots are flying aircraft without licenses. So it's not such a big deal. So you can actually do a lot of this cool stuff. How can you really do this?
Practice. Here you can see fake hand, focusing on it. There's the real hand, not focusing on it, simultaneous stroking. And there are various ways you can test it.
Cool. So you can
Practice.
experiment at home.
Here you can see fake hand, focusing on it. There's the real hand, not focusing on it, simultaneous stroking. And there are various ways you can test it.
So your brain actually connects to machines and different things very spontaneously. So people who lose their arms, in parts of your brain, you often get phantom pain or phantom limb. We don't try to eliminate that phantom limb, but rather tap into it and have that part of the brain still control a robotic arm. And I'm going to show you some of that stuff. So the idea really is that, keeping brain cells alive, we can grow them on a semiconductor chip. They are happy. We had to work very hard to develop biocompatible substrates where they could really hug and talk, and then it's amazing when two brain cells come together. This is like Tiana. So Assalamu alaikum, how are you doing? So this negotiation between them, we can decode the language, and that really allows us to be able to tap into. We can report from up to 100,000 brain cells real time. So this allows us to be able to really gain access to information processing capabilities of the brain with exquisite accuracy. But these brain cells are still sitting on a semiconductor chip, so they sit right interfaced with. But brain is three-dimensional. So the question is, how do you really manage to control a 3D network where brain cells are sitting in a slice, because brain is three-dimensional? So we developed these novel technologies, these 3D electrodes. They actually go right into the tissue, and they can report at a single brain cell level the activity of a single networks of brain cells. But still, this wasn't really enough for us, because still you're reporting from brain cells that are in contact with the chip, but brain is still a three-dimensional. How do you tap into those brain cells that are sitting in the upper area? So we developed another photoconductive stimulation approach. We grow these brain cells on a semiconductor chip, and then when we fire the laser through the microscope, it changes the properties of the wafer, and as a result, a single brain cell fire. So honest to God, what I'm going to show you next, I never thought I will live long enough to see. Okay, so this is it. You can record millions of brain cells at a resolution of single cells using this technology. So now the sky is the limit. You have access to those brain cells that are in immediate contact. You have access to those brain cells that are in 3D. Put it together, what can you do? You can actually now plant these chips inside the animals, whereby this particular monkey has no arm, for example. When you plant this chip in sensory motor cortex, when monkey's visual cortex sees the food palette, it will activate its visual cortex will activate sensory motor cortex, and if you have a chip sitting in the sensory motor cortex, it picks up the activity. Because you designed this chip yourself, it becomes a remote control, and so the robotic arm is also designed by you as well, and you could really pair them in a way that the monkey can control an artificial limb. Now I think with G5 technology and also with robotics, and nanofibers, this monkey would be able to play table tennis. I met a brilliant student, actually resident, and she was interested in epilepsy, so I thought I'll show you one application and then I will end. I'm maybe running over already. So it is to really, how can we develop technologies to still as a non-invasive means? So children who do not respond to drugs, the surgeon has no choice but to go in and operate and take that tissue out. But the problem is that it is very difficult to decipher the precise location as to where the seizures are coming. It's like an electrical storm, right? You see the clouds, the lightning, you cannot predict where the lightning is going to come from. So what they do is that they will plant these electrodes, and the surface electrodes on the scalp surgically. They sit on the surface, so it's non-invasive in a sense. The child is attached to a 30-foot cable in the hospital, and every time this child will seize, they will pick up the activity, but still it's not really accurate. What we wanted to do was to develop a chip which is 200 times more sensitive than conventional ECOG electrodes, but also to make it completely wireless, so the child can go home, and also to make it MR compatible. So we developed these flexible electrodes, and these flexible electrodes, when they're implanted, there's a little backpack, the child goes home, but every time we will seize, because we have also taken an MRI image of the brain, along with where the juxtaposition of the electrodes is, every time this child will seize, the actual software will create a 3D image, a rendition, and send to surgeon, telling surgeon this is the exact foci where the seizures are coming from, this is what I think that you should do, and take those seizures out, that tissue out. So we started out with these 3D flexible electrodes. We planted them in rats for 8-9 months, and we recorded every single seizure. And the idea was that now, after validation, our company won several awards for this particular technique. We got with a bunch of surgeons. When they're planting these electrodes, we sneak in our own electrode and this chip, and when it is implanted inside the brain, it really is, small little dongle that you see here is the one that acts as an antenna and provides the input to the outside device. So the child can go. We are dealing now with Apple for a technology whereby you have cochlear implant. Every time this child is about to seize, it dials your cell phone and it tells you, sit down, you're about to have seizure, I just dialed 911, and I have turned on the GPS locator on your phone, ambulance knows exactly where you are, and the help is on your way. And also calls, in my case, my wife, that you're richer than you think. So we can actually use these electrodes to be able to record, seizures at the single cell level. I think this is something now is going through clinical trials. We think that, starting with these non-invasive approaches will be the first way to take this particular technique that we have spent so much time. I always remind people that drugs and medicine is for patient and people, not for profit. Profit comes. So I think if you make the profit the main mandate, Allah takes away the healing power, and that's why we as a collective humanity are suffering, because the money has become the main mandate. So the shifa comes from Allah, we are only the witness. The moment we see somebody healed, just bow down and say thank you, Alhamdulillah Rabbil Alameen. So for everything else, so I will end here by this particular saying that yes, we can solve all the world problems for something, shadi.com. Thank you very much. Thank you very much.